In this section, we're going to look at absolute convergence and then two additional tests for series to determine convergence. So we look and see absolute convergence. If we've got a series, the sum of a sub n, it's called absolutely convergent if we can take the absolute value of the a sub n's and we end up with a convergent series. A series a sub n is called conditionally convergent if it is convergent but not absolutely convergent. So think an alternating series with a harmonic series, and think the harmonic series. The alternating harmonic series is convergent, but the absolute value of the alternating harmonic series, or just the harmonic series, is not convergent. So that would be a conditionally convergent series. So that was convergent, and this one was divergent. If a series a sub n is absolutely convergent, then it is convergent. So if we can take the absolute value, and the absolute value of the series is convergent, then without the absolute value it is also convergent. So we're going to use theorem 3 to determine whether or not this is convergent. So this is not exactly an alternating series. Cosine of 1, 2, 3, 4, and so on is going to be between -1 and 1. And you see on the denominator we've got your n raised to the second. So we would like to kind of use the comparison test. So what we're going to say is, using our absolute value, we know if it's absolutely convergent, then this is convergent. So if this one is convergent, then this one is convergent as well. All right, so if we look at the absolute value, now we're thinking about the top is going to be between 0 and 1. The bottom, of course, is always positive. So we can compare this with this absolute value of cosine of n over n squared. We're going to compare it with something that we know that is larger that also converges. So I got that backwards. The numerator of the left-hand a sub n term is going to be smaller than or equal to the numerator of the right-hand a sub n term, or b sub n term. The denominators are both the same. So we know, what do we know about this? We know that the sum of 1 over n squared converges because this is a p series with p equals 2. Since this series converges, right? This converges, check. Excuse me. This one converges. It's larger than that one, which converges. Therefore, the one without the absolute value converges as well, and we have answered the question. So this converges because the absolute value of it converged, which we compared with a convergent E series.